Here we're going to take a look at a rational function and find its inverse and see what this does to the asymptotes. So first of all, our vertical asymptote, we get that from essentially the domain restrictions, knowing that the bottom can't be 0, so we'll say, well, what would the equation be if it was 0? And that's where x is 5/2. So 2.5. And the horizontal asymptote we get from comparing the coefficients of the leading terms. They both have a degree of 1, so it ends up just being at y equals 3/2. So if we draw a graph of this function, we can put our vertical asymptote there in red. That's where x is 5/2. That's where the function approaches. And there's a horizontal asymptote in blue at y equals 3/2, so 1.5. Now, algebraically, we're going to find the inverse. So we're going to put it in, we're going to put y in instead of f of x, and now we're going to swap x for y. These are tricky sometimes when you now have two y's. You have to do a little bit of rearranging to isolate the y. Here we'll factor it out, and then divide everything by 2x minus 3, and now we have our inverse function. And if we analyze this, we see that the vertical and horizontal asymptotes are actually just exact opposites of our original function. So now our vertical asymptote is 3/2, that's what our horizontal asymptote was before, and vice versa, the horizontal asymptote is now 5/2. If we graph this new inverse function, it's in the orange, we see that it's sort of a mirror image over the line y equals x. So we'll label them there. Red is the original, f of x, the orange one is the inverse, and there's our line y equals x. We can see how it mirrors, and they share some points at 0, 0 and 4, 4 because they fall on the line y equals x. Essentially, remember that an inverse is just a swap. xy turns into yx.